Good afternoon. My name is May, and our team will present our analysis of the Takeo software cataloger business case, which explores customer purchasing behavior in a direct mail marketing campaign. Takeo, an established software catalog company, conducted a test mailing campaign and collected data on customer characteristics and purchase behavior. The goal is to understand first, Y1 spending amount, how much a customer spent during the campaign, and second, Y2 purchase likelihood, whether a customer made a purchase notated by 1 or not as 0. The dataset contains 1,405 customer records with 13 variables, including transaction history, such as number of purchases last year, demographics, gender and U.S. residency, and engagement metrics such as web orders and last update. Out of the 1,405 customers, 51.25% of the customers made a purchase, while 48.75% did not. To better understand the dataset, we conducted descriptive statistics, visual analysis, and correlation testing on Y1 spending and key independent variables. The average spending is $107.61, but the standard deviation is high at $194.51, indicating wide variability. The median spending is only $22, showing a strong right skewed distribution, where most customers spend little while a few spend significantly more. A box plot confirms the presence of many outliers, indicating some customers spend up to $1,500, significantly raising the mean. Transaction frequency and spending. The average number of transactions per customer is 1.45, with most customers making 1 or 2 purchases. Customers who purchase more frequently also spend more, confirming a strong correlation, 0.7, between frequency and spending. The box plot shows multiple outliers, indicating a small subset of customers with significantly higher transaction counts. Last update days ago. The average days since the last update is 2,125 days, with a high standard deviation of 1,150 days, meaning customer records vary widely in freshness. More recent updates correlate slightly with higher spending, suggesting active customers may be more valuable. For correlation metrics, we've classified some notable correlation into 3 categories. For strongest correlation, Y1 and frequency with 0.7 correlation, the more often a customer buys, the more they tend to spend. Y1 and Y2 with 0.54, customers who made a purchase spend more. For moderate correlation, recency of updates, meaning more recently updated customers are slightly more active. For weak or negligible correlations, gender, U.S. residency, and residential address do not significantly impact spending or purchase likelihood. 2 key takeaways from this is frequent buyers are highest spenders, while recent engagement slightly increases spending potential. Demographics do not play a major role in predicting customer spending behavior. Data partitioning. To ensure model accuracy, we split the data set into training and validation sets separately for Y1 and Y2 analysis. This is our code and partition result for our interface that we will be using moving forward. Now my teammate Yiming will continue on with regression model.
Hi, this is Amy. I'm presenting the second part. So model 1 for Y1, so now Y2 is excluded from this analysis. We're using the training set to estimate a regression model with Y1 as the dependent variable and all the variables in the field as independent. Use a validation set to estimate the accuracy of the model, which means the RMSE. So now we're looking at the result. The regression model explains 53% of the variation in Y1, showing a moderate fit. The f-stats of 88.26 with a p-value below 1% confirms the model is statistically significant overall. However, not all predictors are meaningful. Frequency with the slope estimate of 96.14, p-value smaller than 1% is a strong predictor, meaning customers who buy more often tends to spend more. Address is residential, slope estimate of minus 101.5 with p-value smaller than 1% has a significant negative effect, suggesting residential customers spend less. Other variables such as US, web order, gender mail, source A, source B, and source E do not have a strong impact on Y1. On the validation set, the model's RMSE is 132.4, which is quite high since it exceeds the average Y1 value. Now we're using a stepwise selection method for model 1 with training data to build and estimate more parsimonious regression model with y1 as a dependent variable and all the stepwise selected variable. We're also using the validation data to estimate the accuracy of the model RMSE. And after this, we'll compare model 1 and 2 on RMSE and parsimony. So now we are looking at the result. The stepwise regression model was created using the backward elimination, starting with all variable and removing the least significant ones. This process eliminated 5 predictors, leaving a final model with 6 predictors. Despite fewer variables, the model's explanatory power remains nearly the same. That is from we check the adjusted R squared. They're quite the same compared with the full model. Frequency is still a strong predictor, showing that high purchase frequency leads to more spending. Address its residential remains significant with a negative effect, meaning residential customers spend less. Last updates ago, source C and source D are also significant, while gender male is included, even though it is not statistically important because its p-value is over 10%. On the validation set, the stepwise model has an RMSE of 133.2, slightly higher than the full model's 132.4. However, this 0.8 difference is very small compared to the average Y1 value, the 107.6, meaning the reduced model does not lose predictive accuracy. Since the stepwise model keeps only 6 of the original 11 predictors while maintaining the similar performance, it is preferred for being simpler and more efficient. Now, my teammate Xingfan will present the third part.
Good afternoon. I'm Xingfan, and I will summarize key findings from our logistic regression model predicting customer purchases. First, transaction frequency is the strongest predictor with a coefficient of 2.12 and a significant p-value less than 1%, meaning frequent customers are more likely to purchase. Previous web orders also strongly predict purchases with a coefficient of 1.04 and a p-value less than 1%. Having a residential address negatively impacts purchase likelihood with a coefficient of 2.04. Among source catalogs, source A positively influences purchases, whereas source B negatively affects them. Other variables like gender, US residence, and days since last update were not significant. Now, using the validation set, the model's ROC curve yielded a strong area under the curve, AUC, of 0.862, which is close to 1, indicating reliable differentiation between purchasers and non-purchasers. Using the Uden optimum cutoff around 0.58, sensitivity is about 61% and specificity nearly 90%, effectively balancing correct identifications. I will now summarize our logistic regression model refined through backward selection, retaining 5 significant variables and dropping 6 non-significant variables. Transaction frequency remains the strongest predictor, with a positive coefficient of 2.10 and highly significant p-value less than 1%, meaning frequent customers are more likely to purchase. Web orders positively influence purchasing likelihood, with a coefficient of 1.05 and a p-value less than 1%. Conversely, residential addresses negatively impact purchases, having a coefficient of negative 1.94 and a p-value less than 1%. Among source catalogs, source A positively affects purchases, while source B negatively impacts them. Again, using the validation set, the ROC curve yielded an area under the curve of 0.855, which is close to the original model and close to 1. Then, using the Uden optimal cutoff at around 0.5, sensitivity is about 55%, but specificity improved significantly to nearly 94%, better classifying non-purchasers. Finally, comparing both models, the reduced model achieves nearly identical predictive power, but with fewer variables, improving interpretability and efficiency. Hence, the backward selection model is more parsimonious, practical, and preferable for future customer targeting decisions. Therefore, Model 4 is overall better than Model 3. Thank you very much.